Today's session will be around 1 or 1.5 hours, and the recording will also be available after the session. So, thank you for coming to attend this session. So, let's wait a couple of minutes. I hope we can start the session. Am I audible? Yeah. Hello, is the screen visible or any problem with visibility? Let me know. We can start. I feel the screen size is a bit lower. Let me correct it. Just hold on a minute. Okay, fine. Okay. So, today's session is about the microservices. Hope you are already have some knowledge about microservices. What I plan to cover in today's session is to give you an overview of microservices, and then we can look into some of the services that are offered by AWS or Amazon Web Services. So before we understand about the different service offerings by AWS, we need to understand first what is a microservice and how it differs from other types of architecture. So microservice is one form of software architecture where we split our code base into smaller modules. There is a general reason behind why we are doing such kind of things, because if you know software development, we can understand that if we simply develop an application using a single code base, it's very easy and simple to understand, easy to maintain if it is for a smaller application, as well as it's very understandable. There is not much complexity involved there. But when it comes to microservices, there's a lot of complexity involved. Like we need to split the code base, and there's a specific reason why we are doing it. So first of all, we all understand about microservices in general a little bit, and then we can look into specific microservices. So this will be an overview session. So in case if you feel any doubt while during the session, let me know that I can clarify it. Either I can clarify through the chat or through the end of the session. So anyway, I will be active in that meetup group as well as on my YouTube channel. So I will be clearing all your doubts. Then about myself, I am a .NET developer. I am from Thiruvananthapuram, Kerala state, and I have work experience with working with the different cloud technologies like Microsoft Azure, Amazon Web Services. I am also a community builder of Amazon Web Services storage. In addition to this YouTube channel, I also have a podcast which is available on all the different podcast platforms, including Spotify, Amazon. So you can check about my podcast there. So the name is same as that of this YouTube channel, Coding Talks with Vishnu VG. And all the sessions that are conducting here will be available as recording, so you can watch anytime later as well. So that's all a quick overview about myself, and let's look at the agenda of today's meeting. Today's meeting is first we will look up an overview of microservices, then we look at the specific services by AWS. We understand a bit about microservices so that it can help you to implement your microservice architecture which you understand. So that's all about the session. So let's start. So let's go to the next slide. So this is a microservice definition, one from Wikipedia and also one from Sam Newman. So I like to mention you about Sam Newman because he is a very expert person in this field about microservices. So he has written two of the famous book which we will discuss a bit later. So if you go through that book, you will get a good overview about microservices. So let's first look at what is the definition of microservice from Wikipedia, and we can split the definition one by one and can understand a bit more about microservice. Microservice is an architecture. It's a kind of a variant of the service-oriented architecture. So earlier in the session, we talked about the single code base, and we understood that it's very easy to understand and it's not complex. But when it comes to a maintenance level, it will be difficult to maintain that code base. So instead of having a single code base, as the software architecture evolved, the idea of modular services came into existence, and this microservice is another form of service oriented architecture as defined in this definition, and it's a collection of loosely coupled fine grained services. So modular, our application, a simple application may have a single code base, but this microservice application, it can be considered as a collection of fine-grained modular services, and they will be communicating through a lightweight protocol. So this protocol, you can understand in simple terms, it's a kind of a network way by which it connects. It can be either the TCP, HTTP, or gRPC, or different protocols, networking protocols we can use to connect from one services to another. So you can think of the microservice. One best example is the Amazon shopping website, which we all are familiar with. So if you look into that website, when we open that website, we can see it's a simple website, and there are different parts of the websites, but each part is actually a kind of a fine-grained service. So together all, the entire Amazon shopping website can be think of as a collection of different services. So in this way, you can also develop a microservice architecture, and some of the benefits that it provides are like you can easily manage a single part of the application. Like imagine if you are developing an application as a single code base, what will happen is, like if you want to change some part of the application, you need to change and deploy the entire application all at once. So that will be a bit difficult for you to maintain, especially in an organization, because there might be only a minor change required in one part of your application. So you don't need to bother about other parts at all. So we need a mechanism, or we need an architecture to work on specific part of an application, and that way we can deploy that particular part, and then that way it will help in ease of deployment. Then let's see the definition of Sam Newman. He also says the same thing in a different way. Microservices are small autonomous services that work together. So here the idea is like different small modular services which work in a kind of a communicated way to bring out an experience to the end user. So that is in simple term microservices. So this is similar to the service oriented architecture and other forms of service oriented architecture that you are familiar with, but there is a characteristics which distinguish the microservices altogether, that which we will come as we go along the session. Hope this much is clear for you. If you have any doubt, let me know, I can clarify that. So going to the next slide, this is, we are going to understand microservice a bit more by understanding about monolith. So those of you who are not familiar with what a monolith is, it can be think of as a application with a single code base. So that's the definition of Sam Newman says first. He says, when all the functionality in a system must be deployed together, I consider it a monolith. So the one of the reason or the challenges that faced by software developers is how to change a particular part of a system and deploy it without affecting the other parts of the application. So that is not possible or easy with in the case of a monolith, because it's the entire code is tied as a single code base. So such form of architecture that you all will be familiar with is called a monolith service. So there are different kinds of monolith. So there is single process monolith, there is modular monolith, and distributed monolith. So these you don't need to go into too much deep into all these things, but the idea is like these are different types of monolith. So monolith itself is a single code base, but in the case of modular monolith and also the distributed monolith, there are some specific characteristics, like there may be multiple modules inside a single process and all. It's more for maintenance purpose. They have evolved the monolith into a different way. And also one of the main thing you must keep in mind is you should avoid the distributed monolith at all cost. Distributed monolith means that Sometimes as part of the application development evolvement for an application, initially we have a single code base monolith, and then as we progress along we may create another module, a separate monolith, and that way it becomes distributed. So it becomes some form of like a microservice architecture, but it won't have any benefits that are offered by the microservice architecture at all, because it's all tied to a single database and the different modules are distributed across. So that kind of architecture is called distributed monolith. So you must avoid such kind of architecture because it brings the complexity of a distributed architecture, as well as it also has the problems associated with a monolith. So you should avoid the distributed monolith at all cost. And if you look on the right side, you can see a comparison of monolith and a microservice. So this is a simple application. We can consider it as a blog application where we have a set of users, threads and posts. And you can, by looking into the that diagram, you can understand about how a monolith differs from microservice. In the monolith, everything is actually a single application, has a single code base, and if you want to do some change in the user section, you need to change it in the user section. But the deployment is the main concern of a monolith, where you need to deploy all the application together at once. You don't have the privilege to just deploy this users part. But whereas in the case of a microservice, each one of these different modules or domains are separate modular services. So users can be developed and deployed with your favorite language of your choice. Maybe this users part is a kind of a can be developed using Node.js or some form of front-end frameworks like the React or Angular, and threads can be developed using some other technology, and also similarly post if we can develop using different other way. So each of these different services together form a single application called the blog, but this will be separate modular services, each one, and this will be communicating each other through some form of communication protocol, which is called the which can be kind of in simpler, most of the cases it will be like an HTTP protocol or an HTTPS protocol, and in some cases gRPC protocol also can be used to communicate with other. But for the sake of understanding, in simpler terms, you can consider it as communicating using HTTP or through an API. Each will be communicating to each other. So this also shows one other characteristics of microservice, that is implementation hiding. Implementation hiding is a characteristics of software where a particular implementation for a particular module is hidden within that module itself. So this thread module have no idea about what the users module is doing. That means we can hide the complexities all inside the users. But what about if the thread module want to communicate with the user module? Then we can provide a kind of an API like interfaces. It can be kind of a public interfaces where one module can connect with the other module. Similar way, the post module also is a separate module which has its own implementation, and if the post module needs to connect with some other services, it can connect via HTTP, but it cannot know the exact implementation inside these threads and users. So this is the characteristics of these software called the implementation hiding. So this offers a lot of benefits, because imagine if in an organization there is a set of teams working for this particular user service, and another team is working for this thread service, and a different team is working for post service. And if someone wants to change something inside, a particular team wants to change something inside this user service, they can do that provided if the public API or the contract between that they are that are visible from this user service hasn't changed. So the internal implementation can be changed anyway as they like. So that's one of the benefits that are provided by microservices. Similarly, if this threads module which is owned by a separate team, so if they have some improvement they want to include it for this thread section, they can do that without affecting the other parts of the application. So this way, implementation hiding can sometimes be benefit to the microservice development. And another major thing is like one of the main question that many of the people that are confused with is like whether each of these modules in microservices needs different database or whether they can use a shared database. So the suggestion that is provided by experts like the Sam Newman and others in this field, and there's a reason also why they are providing that suggestion. So the suggestion is like we should only use individual database for each one of these services. So users have its own database, and the threads have a separate database, and also post have a separate database. So if one module needs some form of data from others, it can request via a public provided API that is provided by this users team. So this way implementation hiding exists there, and the separate teams have the has less dependency with other things, so they can do whatever they like until their public interfaces is not changed. So this way separate database is a must for implementing the microservice architecture. Then only the independent deployability can be possible. So imagine if there is a common database that is shared between these different modules. So this is an example regarding a blog post. So same example you can relate with other kinds of applications as well. So you can relate this same with your the one with you familiar with the Amazon website or Spotify or whatever application you are familiar with. Most of the today's enterprise applications are mostly a form of a kind of a microservice architecture. So there these kind of different modules, if they are sharing a common database, what happens is like if some part of this team is working on that database and it's using by another team, they don't have the privilege to entirely alter the database as they like, because it will affect the other part of the application as well. And similar way, if there is a change that is made to a shared database by a single team, other modules also needs to be updated along with. So it's kind of an actually adding a dependency to the application. So we should avoid a shared database at all cost. The only area where the shared database is allowed is when we are using a read way to get something from the database. So if there is a database that needs to be shared, it should be only in a read mode. Otherwise, individual database is what we prefer. So at this point, you may be confused with how to implement this kind of architecture, because we usually resort to using a shared database, and we may be familiar with the different modules and all, and we may be familiar with connecting that to a common database. But at this point of understanding or of having a separate database, you must be having a bit tough to understand how this to implement and all. So we will understand, once you understand more about the microservice, those things will be familiar to you. So going to the next slide from here, we are going to understand the layered architecture versus the microservice. Earlier, in the previous slide, we understood about the monolith. So monolith is a kind of a single code base, and microservice is kind of a different modular services which are connected each other. Now we are going to understand the microservice in terms of layered architecture. Many of you might be familiar with this layered architecture. Layered architecture is an old approach where the code base is broken based on the teams or technology. So you might be familiar with many of the .NET applications and Java applications having different tiers or layers. So if you open a solution in .NET, you can see like a presentation layer, a database layer, business layer, and so on. So that's a classic example of layered architecture. It's also called as entire architecture. So the idea here on this layered architecture is, Here the code base is broken based or splitted based on the teams or technology used. So if a company has a set of UI developers, so this layered architecture can help that team to work on that part of the layer. Similarly, if there is a business layer, the business layer experts can work on that part. Maybe that's a server side technology like a C# or Node.js or some form of server side technology can be, and those who are familiar with the business requirements and all, they can work on that layer. And similarly, there is another layer called the database layer, where that database related connections and everything is defined there. The idea by which most of the applications were using this database layer is to with the idea that they can change it later to a different database technology, like from SQL Server to Oracle or something like that. So with that idea, they are introducing these different layers. Actually, the problem with this kind of architecture is like, if there is a change required in one part of the application, you need to be aware of the change in all the different part of application. So here different teams can work in isolation, like the DB experts can work on that DB layer, or business domains experts can work on that business layer, UI experts can work on the presentation layer. But when there is a change that needs to be reflected across the different layers, it will be challenging. Like one team, the ownership is not ownership is limited to one layer. So if there is a change required in the application, usually it's communicated to all these different experts, and then the UI person might be actually changing the front end part, and once they have done that, they have communicated that to the server side person, and maybe they will change the API or something, and finally the communication will be done to the DB side. So the order by which this communication happen may vary, but actually the communication happens to these different streams of users, different streams of developers. So this is not actually useful for a customer, because actually it consumes a lot of time, especially this communication between these different layers. So it's actually not useful. So as the software architecture evolved, there is a separate kind of architecture came, that's called the splitting the code base based on business domain. So microservices follows that same concept. So that this is one of the important distinction that you should be aware of. Many developers wrongly think that actually layered architecture is also kind of a service oriented architecture, but layered architecture, there the code base is splitted based on the teams or technology, like the UA teams, DB teams and all. Similarly, but in the case of a microservice, the code base is based on business domain. So that means that instead of splitting the code based on DB experts or UA experts or presentation experts or whatever, instead we can break the code in microservice with the concept of a business domain. So take the example of a shopping website, where the shopping cart part can be considered as a individual business domain, and also the payment service can be another business domain, warehouse service can be another business domain. So the clear distinction between these is that in the case of this, instead of owning a particular part of the particular portion of your code base, here a team owns the entire domain all at once. So this in the case of an Amazon website, take for example of a shopping cart service. So that's a microservice, and that entire microservice is owned by a single team. Similarly, the payment service is also owned by another team. Warehouse service is also owned by a separate team. Review service is also owned by a separate team. So that means that team is a kind of a modular team, where that team involves experts from all different fields. Like it involves experts from UA experts, DB experts, as well as a person who are familiar with the DevOps, and also it might be a small team which they can manage each individual service, but it consists of a mix of different technology person. So that's the kind of approach which actually closely relates to an organization, and it provides more benefits to the customer as well. So that's how the microservice architecture became more popular, because in here, if you think about here, if you want to change something in a particular area, it needs to be communicated with all the different persons. So there is a friction of communication happens in most of the organization where these individual experts work in silos. There needs to create a ticket to communicate on request to another team, and they need to wait for them to create that and all. So that's actually time consuming, so and not provide any valuable value for the customer. So instead of that, a particular domain or the business domain can be owned by a single team, and they can, without having any dependency with other team, they can simply own that service all at once. And another thing is, like, a team can own multiple services as well. For example, if a team is capable and they have knowledge about these two different microservices, they can own two all at once as well. So the ownership is important. It should be owned by a single team. And the another idea is, when you develop an application like this in the form of a microservice architecture, as far as possible, try to not share the code between these different services. So many of the architecture in patterns which we follow, there is a tendency of code reuse. So don't repeat yourself is a principle which many of you are familiar with. But in the case of microservices, we need to kept aside that principle, and instead of that, we need to think in terms of microservice, and we need to reduce the sharing of code between these different services. Sharing, what the problem happens is, like, if you create a particular shared library and it is shared across these different services, it actually brings a kind of dependency among these services. So if there is a change required in on that shared library, it needs to be reflected in all the different modules or these microservices all at once. So it's actually not good, or it creates a lot of dependency among the different services. So we need to avoid that. We need to reduce the shared library all at once. So many of you would think, like, in case if I have a shared library which is shared among these different services, how can I implement that in microservice? The simple answer is, like, you can copy that code to different modules, and you can reuse. You can that way copy it, and then you can use that instead of reusing from a shared library. So that will be more beneficial in terms of reducing the dependencies in microservices. So we can go to the next slide. So here, the one simple microservice architecture with the AWS service is defined here. Typically, monolithic applications are built using different layers. That's a user interface layer, a business layer, and a persistence layer. But in the case of a microservice, the central idea is to split the functionalities into cohesive verticals. So that means this can be treated as a simple payment microservice. Similarly, another form of same kind of the microservice exists for shopping cart service. If there is a review mechanism in a shopping website, there will be another similar kind of microservice exist for them, and each on how the user interface, compute implementation, and data store, but together it's actually a microservice. So this way we can split the code not by technological layers, but by implementing a specific business domain. So that's another thing. Then next we go to understand about the different microservice architecture, its benefits and the limitations. So you might be thinking, what are the benefits that are offered by the microservice architecture if I implement that? One of the things you must consider in mind is, like, microservice architecture is not suitable for a trivial POC kind of application, or if you want to have a application which is served by limited number of users, or it not has any scope of scalability, then microservice architecture may not be the best fit for that, because microservice architecture, its implementation itself has brings its own challenges and all. So if you implement the microservice architecture for a smaller teams, or for a application which has not the scope for a for attracting a large amount of users, then there is no point in implementing the microservice architecture. You may better resort with a kind of a monolith architecture in that case. So that's one of the reason why for every application development, if you are not familiar with an architecture, you can better start off with the monolith, and as you progress along, if you find the scope for extracting it to a microservice, you can have the provision to do that. But if you start with a microservice and if it's not suitable for that application, it brings additional complexity. Because how it brings additional complexity is like when you split a code base based on the business domain, you need to split it properly. You need to follow the principles of implementation hiding. You need to implement proper interfaces between these different services. In addition to that, there are a set of things you must be aware of, like these different services are communicating through a network protocol. All the different disadvantages that are associated with a distributed kind of architecture can happen for this microservice architecture as well. You must keep that in mind when developing a microservice architecture. So if you are familiar, if you want to understand a bit about what are the different kinds of pitfalls that are associated with a distribution architecture, you can Google that. Just Google the limitations of a distributed architecture or the disadvantages of distributed architecture, and you can see a lot of problems that are associated with distributed architecture. Because the problem there happens is like you are splitting the different services and they are communicating through the network. We assume that these services can communicate because we understood, okay, our bandwidth is fine and everything is fine, but things can go wrong. Sometimes the network may slow down, sometimes the bandwidth may get affected, and sometimes even maybe the communication also won't happen. So when a one service tries to communicate with other, maybe that communication fails. In that case, it should automatically retry, and it should try to attempt to connect at the next possible attempt. So that all things you must consider when developing the microservice architecture. So the problem here is like it's not easy to consider all these different parts initially. So it takes time. So you must think about twice whether an application requires microservice architecture or not, because nowadays the container technology and the Docker, everything is popular. So whenever a new application gets started, everyone gets think about, okay, let's start with a container application and all. But if that application has not scope for a scalable way, then it's an overkill to include a microservice architecture for such a kind of application. So let's look at some of the benefits that are associated. So if you find that, okay, our application needs this microservice architecture which has scope for scalable, and in the future it can attract a large number of users, then definitely you can consider the microservice architecture there. And some of the benefits that it offers are freedom to use different technology stacks for different users. So we can understand this in terms of an example. Let's take the example of Amazon website itself. So imagine, this is just a hypothetical example, like the exact implementation of Amazon website will be different, but let's understand this, like freedom to use different technology stacks for different services. Like if there is a module like a cart module or a payment module needs to develop using some familiar technologies that an organization has a set of teams that are familiar with, they can choose that technology to bring the best out of that module. So payment service can be developed by one team that are familiar with these kind of payment developments, and also if there is a team which has experts in UI like the JavaScript or Angular or React, they can work on the front end service as well, like the shopping website itself. So that way there is a freedom to use different technologies. There is no binding like every team should use a single technology all at once. Then second one is increased reliability. That means if you are changing some part of an application, or if one part of your application goes down or one module goes down, if it is a properly well architected microservice, then that failure of one service does not affect other, and the moment that service is back, then it will continue function as expected. So that's called the resiliency, and that's also that's a kind of a reliability, and that also is one of the benefit that is offered by the microservice architecture. Then independent scalability. This can be think in terms of cost reduction as well. When we use the cloud, actually we are paying money. So as far as possible, we need to reduce spending money for our application. So we should have the provision to scale up and scale down. When there is a peak load happening for our application, then at that time our application must scale to meet the needs of the users. And similarly, if there is no need for such scalability, we need to scale down as well. So automatic scalability, which that is provided by many of the cloud providers like the Amazon Web Services, so that part is called the scalability. So independent scalability, you can independently scale a particular module as you like with the help of these microservice architecture. That means your the front, if there is a peak load happening in the front end, you can scale up that front end part as you like. Similarly, if there is a processing power required for some particular background service, you can scale that module as well. This way, independent scalability, scale up and scale down can be possible with the help of microservice. And you can put all that behind a load balancer. So there is a load balancer which serves the incoming request from different microservices or users, and behind that you can have a couple of different microservices. You can have a maximum number of instances or minimum number of instances as you like, and you can scale it and scale down as like. Then independent deployability without affecting other services. If you read the book of Sam Newman's, which is called The Building Microservices, you can understand that he mentioned several times like independent deployability is one of the key factor that or the characteristics of a microservice. If there is one thing you must take from that book, he mentions that it is independent deployability. That means whenever we develop an application with different modules, if someone is asking like, can we deploy that part of application without affecting the other parts? If the answer is yes, then independent deployability is there. If the answer is no, that means that there is a dependency for that service with other microservice, and we need to rethink our architecture a bit so that the independent deployability should be possible. Then the ownership of team aligns with the organization. In the case of the layered architecture, which we thought earlier, actually we can see that there is a code split happen based on teams, but the communication between teams is not happening properly there, and it also, such form of layered architecture not serves any purpose from a customer point of view. So the most in the microservice architecture, the team actually aligns with a kind of a business domain, because each module is splitted based on business domain. So it acts actually benefits the customer, as well as it mostly correctly aligns with the organization, and also reduced dependability with other teams. So this is one of the principle of implementation hiding that is offered with the microservice kind of architecture. If properly architected, the microservice architecture can hide the implementation. In that way, one team is not depending on other module other than the interface it provides. So if that team takes care of the interface and it doesn't break that interface, that brings them the possibility to change the underlying implementation details as they like. So that means more freedom for individual teams with a reduced dependency with other teams. Then some of the limitations, let's look on some of the limitations that are associated with the microservice architecture. One is like the debugging experience and monitoring will be harder without proper log monitoring. So this is one thing you should consider when implementing the microservice architecture. There should be a proper logging mechanism in place when you start microservice application development, be it like a one or two microservice initially. Then also you should consider logging at the beginning stage itself, because otherwise you may not have a visibility of what is happening behind the scene. Like we discussed earlier, one microservice will be communicating to other microservice via the network. Sometimes the network fails and you should have a visibility like where that fail happens. So to happen, you need a proper logging mechanism in place. This is one of the main problem that are faced by many of the developers. Like they start microservice development without logging at all, and they think like, okay, after implementing every microservice we can implement the logging, but this will be a problem. Like you don't have any visibility like a monolith what is happening behind the scene unless there is a log monitoring in place. So log monitoring is a must. Then you can check about the distributed computing and the disadvantages it brings, and those all applies for this microservice architecture as well. Then another thing we already discussed, like it's an overkill for small teams or for a trivial projects which has no scope for future. Then another thing is increased cost. So microservice architecture itself is actually a bit complex, and you need specific deployment mechanisms like the container, Kubernetes and all for deploying a proper microservice architecture. You can have a microservice architecture even without a container or a kind of a Kubernetes or anything, but most organizational applications needs such things to properly orchestrate all the different activities of a microservice architecture. So that means it increases the cost as well, but it has its own benefits. Like you can change a particular part of the application and you can bring that into production as fast as possible. That benefit is there, but at same time it's increased cost. The final thing, it's not it actually these are some of the points I captured. You can check out the book Building Microservices for more details about understanding the different limitation. So some of the points I have captured and presenting here, like the reporting can be complex. Like take the example of a single code based application where you can have the everything from that code base itself, and you can present that to a front end user. That will be much easier. But in the case of a microservice architecture, you may have a couple of different modular services, and you need to aggregate all the different services and its logs, and sometimes collecting the data from there and presenting to the user can be a bit it's not that much easy. It can be complex, but some of the patterns can be used, like backend to front end pattern is there, like the BFF. So what it does is like it collects all the different reporting details from different services, and it aggregates that and it saves that to another database just for the case of reporting purpose, and that way it can help in the reporting purpose as well. So these are some of the limitation. But there are ways to mitigate these limitations, like by proper implementing the logging and monitoring. The first thing can be mitigated. Second, on the like introduces distributed computing and its disadvantage. There is also ways to we can mitigate that by implementing the retry, and we should develop the microservice architecture with these distributed computing in mind and its pitfalls in mind. So that way we can avoid some of the challenges. Also the reporting we can improve by including some of the patterns like the backend to front end patterns and all. So this way we can mitigate some of these limitations. So next we going to understand about the development strategies that we need to follow when we plan to develop a microservice architecture. Here you can see two columns, like the one is for new project and one is for migration from monolith. First we can look on the new project. So you are going to start a new project. First analyze the requirements, check whether there is any scope for improvement in that project, and if there is no scope for that project, then there is no point in including the microservice architecture there. You can safely go with a kind of a monolith. So that is also one of the default architecture which you can rely upon if you are not familiar with any of the different kinds of complex architectures at all. Simply go for monolith if the application you got from a customer has no scope for further improvability. But if there is an improvability and there is a scope for improvement, then that is a good candidate for microservice. What you can do is you can model that requirements with domain driven design. So this domain driven design is entirely a different subject which needs a separate session at all, but you can Google it. Actually it's splitting the requirements based on the business domains. So a properly splitted code base have different domains, like as we understood from the shopping website Amazon, where payment is on business domain, the shopping cart is another business domain, then the warehouse can be a different domain. This way, if you properly design according to the domain driven principle, then you can easily map that to a microservice. So that's the next point defining, like each domains that are mapped by this domain driven design can be a candidate for a microservice. You might be thinking, how can we derive a domain from a domain driven design? So you can go and read the book Eric Evans' Domain Driven Design, and also there is a book called Domain Driven Design Distilled. There are also other books in this from the same area. You can check out that, and you can have an understanding of the domain driven design. And there is also a process or an exercise called event storming. So the exercise is simple, like some of those who are familiar with the business requirements join a meeting and they collect all the different requirements and they find out the aggregates, the events and all, and thus they derive a domain. So that's called the event storming. You can check out that as well. And also there is a process called a 7-step seed process, which can also help to decide the domains. So these are outside the scope of this talk. So I just mentioning about those things. If you are interested, you can search that. There are a lot of good resources available there, in those area. If you are even if you are not familiar with all those things, still you can go through the architecture or based on the go through the application requirements a bit more. And if you find that if there is a specific area in your application that needs change frequently, that can also be considered as a candidate for the domain for the microservice. And one thing you need to keep in mind is that you can start smaller. Incrementally you can add other microservice. So that means you can safely start with a monolith and you can consider developing one part of that application as a microservice, which is absolutely fine. And as you evolve, the application evolves, and when your users starts using that application, if you find that bringing some or extracting some other portion of that monolith to a microservice provides some additional benefits, then you can think about extracting it. So that way you can change. Then this is another thing, like try to implement gradually one by one. Start with a monolith if you are not sure. And also when you implement the microservice architecture, the concept of transaction is not there. Like if you are having a monolith or a single code base, the idea of transaction can be easily implemented. But in the case of the microservice, you need to resort to saga pattern or orchestrated or choreographed saga pattern to implement the transactions. It's not exactly similar to transactions as you seen in the SQL Server, but it's somewhat similar to that. There is a blog article which is written by Sam Newman related to this saga pattern. Also, it is also mentioned in his books like the Building Microservices and Monolith to Microservices. Go through that. You will get a good picture about how to implement the saga pattern, because most of the applications need transactions. You need to have a set of workflow that needs to happen, and you need to roll back it as well. Sometimes if in most of the business application, usually there involves a workflow, like on in step 1 this will happen, step 2 that will happen, step 3 that will happen, and so on. And then there is a we need to revert back if something wrong happens. So you can resort to this saga pattern in that case. So these are the considerations you should be aware of when developing a new project. And what about when you migrate from an existing monolith? Imagine if you have a application that's a legacy application that is built using some form of older technologies, and you want to take advantage of cloud and microservice. First of all, analyze the monolith, find out the areas that require frequent code changes, and then you can extract it to a microservice. Sometimes organization come up with a challenge to convert their sometimes organization want to adopt cloud or migrating their application to cloud. There they can start off with a lift and shift approach, where they can entirely take their existing legacy application as it is and install that with the dependencies onto a VM or something. So that's called the lift and shift pattern. And then incrementally they can split a particular portion or specific portion of the application which needs to be modularized or converted to a cloud-based microservice. Then you can extract that. So there is a pattern called Strangler Fig pattern that can also be helpful in that case. So these are some of the books. These are 2 books that are written by Sam Newman. I recommend you to go through these 2 books. One is the O'Reilly Building Microservices. Second edition is there. And second one is the Monolith to Microservice. First you go through this book and then to this book. So you will get a good idea about implementing the microservices. Then now I hope you understand a bit of familiar with what a microservice architecture is. I will provide a summary again. Microservices are independently deployable. Microservice is a form of an architecture of application development which involves modular services and which are communicated by a well-defined contract. So the idea behind this is to improve the independent deployability as well as the maintainability of the application. It also provides additional benefits as we saw in the earlier slides. Now once you understand this, let's think about how to implement this on Amazon Web Services. So you can have a microservice and you can entirely deploy that onto an on-premise machine that you have. Maybe your organization have some form of an infrastructure where it has a set of VMs and all. You can entirely deploy that in that VM at all. So when it comes to microservice, it's kind of an architecture, but to get the most out of that architecture, you need to deploy that properly, and you need a infrastructure also to take benefit of that microservice architecture. You can have that deployed on a VM or individual machines, but that is not a cost effective strategy, because what happens is that If you have 10 microservice and if you want to deploy that onto a VM, then it means you are actually using an entire system like a VM for a single microservice at all. So that's not a cost effective strategy, especially when it comes to cloud. If you have an infrastructure and a set of dedicated VMs, you can use that, and some companies are doing that way. But when it comes to a customer oriented application development, so purchasing those kinds of VMs and providing that VMs on the fly will be not easy. And another problem is like when you want to deploy the microservice, you need to have different instances, because then only according to the increasing demand or the load of the application, you can cater the users accordingly. So at that time you need to increase the VMs. Maybe you need to increase the VMs from 1 to 100 or so on. So that is not possible when it comes to, or not possible or not easy if when it comes to an on-premise infrastructure, because organization need to have purchased those machines in advance, and that is not a cost-effective strategy. And also for implementing all these VMs and all on-premise, it's a bit challenging. You need to go through a set of different process even that to happen. Sometimes the finance may not approve that. So that kind of approach is not feasible nowadays. So modern the trend is like depending on the cloud services like the AWS, Amazon Web Services, or different other cloud providers like Microsoft Azure, Google, or something. Here in this session we are mostly focusing on the AWS services. So we can look into how we can implement a microservice or deploy a microservice in AWS, and what are some of the specific services that are offered by AWS in that case. So let's take a 2 minutes break and we will resume from here. In case if you have any doubts or anything, let me know. I can clarify that. So there are a few more slides as well. We can try to wind up the session as far as possible. And also there will be a upcoming session on how to have a hands-on on these different services that are provided by AWS as well. But if you check the further part in this session, you will get a good understanding about the different cloud offerings that are provided by AWS when it comes to microservices. There are a lot of different services. Together I think around nearly 200 services that are offered by AWS, including storage, AI, deployment, then machine learning, and different kinds of services are there. So if you are new to cloud computing, then I recommend you to create a new free account on AWS. So once you create let me share my screen and show you. Just hold on. Okay. So you can create a free account. Just Google creating a free account in AWS, and you need to sign up. Initially you need to provide your credit card as well, but that won't get charged because AWS offers a set of free services. You can check that and if you are within that limit, the credit card won't get charged. So what you need to do is like once you sign on to the AWS, you can check on here. You can see the different kinds of cloud offerings that are provided by AWS. So AWS provides these services like a pay-as-you-go model. Like if you are using a database service, you need to pay for what you use. So that means companies don't have to advance procure anything for this kind of application development nowadays. So if, for example, if an application needs to store something in AWS, they can select this S3, which is called an object storage, scalable object storage in the cloud, and you need to pay only for what you want to use. So it's not just about the storage. It's S3 provides many additional features as well. If you go through the documentation, you can understand a great deal of information about those as well. Simply, this can be considered, think of as an object storage where you can store any kind of files and all. But if you go deep into that, this provides additional benefits that each of these services provides additional features that are helpful for software development. So let's take a 2 minutes break and then we will resume understanding about the specific services in AWS that can help with your microservice architecture. So we'll be back in 2 minutes. Okay, there is a question. For microservice, is server required or serverless? Actually, in the next set of slides, we will be discussing those things. You can go for any way, like a serverless or server required way. Serverless actually means we are directly using some of these services without bothering anything about the infrastructure at all. That means you can focus more on the business logic and all, but you need to architect your application in a serverless way. And another problem with that kind of approach is like, even though is it required S3 bucket is actually on service that is offered by Amazon. It can be helpful for microservice development. So imagine, take a simple example of a microservice architecture where you have a front-end website, okay, and there are two background services, each on two different microservices. One is for image processing and another one is for file processing. S3 is an object storage. What happens is that when you want to store something as part of your application, you need a dedicated space for that. So S3 is such a service which you can use from Amazon. So most of the microservice architecture involves, or a microservice application involves some form of storage required for that, and you need some storage. You can have a server on premise, or you can have a VM taken and then you can dedicate a space in that VM for storing the files, but that is not a cost effective strategy because you need to pay for that VM, or if in case of an infrastructure, your own infrastructure, you need to pay or set up that machine. And another problem is like security, like in case if there is any vulnerability that is associated with that operating system. See, for example, if there is a VM that needs to have an operating system, and that operating system needs to get patched as well. So you need to bother about a lot of things. But in the case of S3, you can simply create a bucket in S3 that provides a space. It's similar to Google Drive, which you may be familiar with. Simply create a drive, a kind of a folder, and you can store the files, and you need to pay only for what you are actually using, and the rest of the things like the patching, the security and everything will be taken care of by AWS itself. So that's one of the benefit. And S3 is actually not part of a microservice at all, but most of the microservice architecture, when it comes to most of the microservice architecture, when it comes to the practical example, we need some form of file storage or object storage. So in that case, S3 is actually required. So the next question is like, how can we design microservice architecture before start of a project? So first thing we can do is like, you need to have an understanding about the domain-driven design. So there are a lot of books and articles on that subject, videos on that subject. Once you are familiar with that domain-driven design concept, then based on the requirements that are provided by the customer, you can decide the domains. If you think about the shopping website Amazon, you can understand it very easily because many of the examples are already provided, like the different domains. Business domain. A domain means an entity which can be treated as a microservice. So the payment can be on separate domain by itself. Similarly, the warehouse domain can be on separate domain by itself. It's not initially it might not be easy for you to extract that domain you need to have some familiarity with the domain driven design at all, but it will be possible. And even if some domain we split it properly, then also it has the scope for further splitting up. So it's an ongoing process. So initially you can start with a monolith, and initially you can extract one area, one business domain, and you can start off with a microservice architecture. So basically that will be a kind of a decision needs to take based on the requirements and based on the principles of domain driven design. There are two books on that subject. One is Domain Driven Design by Eric, and second one is Domain Driven Design Distilled, which you can check on Amazon. Both these books provide useful information about how to split the domains. There are other books as well on this subject, and a lot of Udemy as well as other videos, or even from within the AWS there are different videos that are available. You can, or from the YouTube also you can have that. The main idea, the core idea behind we splitting a application requirements into specific domains is that then we can easily map that to a microservice very easily, and that will be a proper mapping as well. Because unless there is a proper mapping happened based on that business domain, what happens is, like, if you wrongly create a domain and after some point of time you think that okay, this domain is tied to some other domain, and then we at that time we need to rethink about our architecture. Instead of that, it's better to have a familiarity about this domain driven design in advance, and then look at the requirements in more detail, and that will provide a lot of information. So there is also a step called event storming, where all the different people that are involved with an application, like the stakeholders, developers, and everyone assembled together inside a room, and they start discussing about the different requirements. And initially they don't think about the domain and all, they simply capture the requirements on a whiteboard, and once they capture the requirements, then they start to create a flow. Flow means what all different actions that are involved in that application, and they try to identify the different entities or the persons that are associated with that application. So in the case of a shopping website, there might be a set of users that are using the application. Then there might be a set of admins. So these are different kinds of person, and they capture all the different things and then the different events that are related to that application. In this way, they finally form a kind of entities and aggregates, and these aggregates together form the one business domain. So that's a exercise that's helpful for this identifying the microservice domain at all. You can blindly go with a microservice if you are familiar. For example, if it is a simple application, I have seen many of the developers actually starts a microservice architecture like Docker or something with a front end. So if it's a simple application, let's take the example of a website. I have seen a lot of application where the one microservice will be like the front end, like the React or the Angular or JavaScript website. The backend will be an API, that will be another microservice. And if there is another some background processing that needs to happen other than the API, that will be a separate set of microservice. So that way also you can go ahead. So there is no defined way to do that. There are set of couple of different ways which any way you can resort to. So let's take a break and come back within 2 minutes, and we can continue the session. The recording will also be available, so you can watch it anytime later. You need to sit in a stretch and listen all this. So anyway, I will be continuing the session, but you can watch it at a later time as well. So anyway, let's take a break and come back. Okay, let's continue the session. So far, we were trying to understand about the microservice, some of the benefits, its challenges, and all. Now we are specifically looking into some of the microservice architecture and the services that are offered by AWS. So, continuing from the previous example that I mentioned, think of we have a think of we have. Am I audible? Some of are mentioning not audible. Is it audible now? Hello. Hope it. Yeah. Thank you. Okay. So another question is like why we choose cloud microservice architecture. Yeah, the reason why we go for a cloud microservice architecture is for cost effectiveness. You can have a microservice architecture and deploy that on premise in your VM, but that's not cost effective because we need to pay for the VM. We need to think about the security of the VM. We need to patch the VM and all, and it's not a cost effective strategy because a complex microservice architecture can have a couple of different microservices. Maybe it can range from 10 to maybe even hundreds of microservices in extreme cases and maybe more. So the thing is like if you are going to deploy that on an on-premise VM, it will consume a lot of problems. So we usually go for some kind of a cloud architecture because for the the benefit is like just like we use electricity from a common provider in our home, we don't create our own generator and all in our home and create electricity, and instead of that we usually goes for some shared model like we purchase electricity from some provider, and that way we use and we pay for only what we use. So similar way, for complex or massive organizational architectures, for the organization it will be good for to choose some form of cloud services, maybe for one or two trivial projects like a freelance project, project or some form of a smaller projects, cloud architecture may not be feasible, but for the organization going to the cloud has its own advantages. So that's the reason why these cloud services like Amazon Web Services become massively popular, and now more and more vendors are coming into this market. Like Microsoft Azure is also another provider, then Google Cloud is also another provider. So there are advantages of using cloud, provided if we use that in a proper way, but it may not be feasible for a smaller projects, or if it's not have that much scope, then cloud may not be required. So that's the idea. I hope that will be clear. If any further questions, you can ask that. I can clarify that. So let's continue the session. So think of you developed an application, or you decided to develop an application, a simpler application we can take in this example, like a simple microservice architecture with a UI front end that is developed using React or Angular, or whatever framework or technology that you are comfortable with. Technology is not relevant here, because any form of thing you can create that in a PHP, Python, Django, or whatever you like. Then similar to that, let that application also has 3 different background services which can also be considered as separate microservices. So you have such an application. Now let's understand about how you can deploy that and serve to the customer. So there are 2 different strategies nowadays. One is the container approach. So when I say 2 different strategies nowadays, I am mentioning about the most popular strategies that are available nowadays. One is the container strategy, which is the most common form of strategy, and another one is serverless strategy. Each one has its own distinct benefits. The benefits, first we can look on this container approach initially, and then we can look into some other forms of the serverless approach. So let's take at this container approach. Imagine if you have an microservice application with these UI frontend and 3 background services. You need to deploy these into totally how much? 1 for frontend and 3 background service. So totally 4 microservices are required. You can host that on a VM, but that's not cost effective. So you are trying to deploy that into some form of container technologies. Container technology, there are different technologies at all. So for simple deployment, you just need to have something like this, like AWS Fargate or Amazon EC2 or AWS App Runner or something. You can simply deploy that into a container, and you can serve that to the customer. Each one of these services have different options as well. So this might be, I hope you can see my cursor clearly. So this might be okay. So this compute set of services that are provided by AWS should be sufficient for most of the needs, like a simple deployment of the containers. 4 containers we have, and this should be enough in most of the case. But what happens is, like, these have some limitations, like if you want to have some cluster management, or if we have a lot of different microservices which like more than 10 or 20, managing all this individually using these things are a bit challenging. In that case, we need some form of orchestration as well. So that is possible with the help of these orchestration services. So the main thing to understand here is like all of these, let's leave this last one, tools, that's a support like a service. Let's take the example of this orchestration and the compute. So this orchestration and the compute provides its own benefits. The orchestration is required if it's an organizational application which involves a massive users, and it has a scope of a lot of modules, microservices at all. It will be challenged to manage using a simple compute like AWS Fargate or Amazon EC2 or AWS AppRadar. In that case, you should go for the Amazon EKS, which is an Amazon's implementation of the popular Kubernetes service that is offered by the Google. Also, there is another one that is offered by the Red Hat, which is also available on AWS, and which is called the Amazon Red Hat OpenShift. Similarly, you can also deploy that into Amazon Elastic Container Service as well. So let's, I will explain the steps that usually what we are going to do. First, take the example of a microservice application. Our microservice application has one front-end microservice and 3 background services. So total how much? 4 microservices are there. We can deploy that either into AWS EKS. So the step is like, first of all, we need to make it as a Docker container. So imagine this is a React application, this front-end service being a React application. You can simply add a Docker file. So Docker file, you can add simply a Docker file, and you can make it as a container image. So the what is defined inside the Docker file is more important. Inside the Docker file, we will mention like a base image. So Docker, I'm not going too much deep into the Docker technology or not, container technology or not. Basically, container can be think of as like a shipping container. To understand this easily, let's take an example of a application, the front-end microservice that's being a React website. A React website has a lot of dependencies like the that React application, then that npm dependencies and all, and it needs to be run on some form of operating system. So all these are dependencies. So here in Docker, when we say about making it as a container, what we are going to do is like we add a Docker file. We specify a base image, which is an operating system. It's a minor version of that operating system, and along with that we will specify the dependencies that are required for running this microservice, and together we will make it as a container image. So that means it's like a shipping container which has everything needed for running that application. So that means no external dependencies are required. Maybe you are familiar with some applications where when we plan to run that application, it will say like this dependency is not installed or something. The reason, because that application has a dependency which is not there in the that target machine. So you need to install it separately. But in the case of container image, it's a lightweight shipping container like thing which has the entire application plus the required dependencies and all, and that's called a container image. So you need to deploy this container image in AWS Elastic Kubernetes service. The idea behind this is that if you provide this container image to EKS using a well-defined DevOps pipeline, that means once you in your local machine, you may be changing your application and you can run that locally inside the container with the help of a Docker desktop, and you can verify that everything is working fine, and you make it as an image, and then you will supply that to AWS EKS using a DevOps pipeline. So next thing, what the AWS EKS is doing is like, based on what you defined, it will automatically deploy that to the required instances and all. So if you want to have one instance of that container image, AWS EKS can do that. So EKS, this Elastic Kubernetes Service, is an adoption of the popular Kubernetes service that is developed by Google. It's initially developed by Google, and it became popular because in most of the real world applications, this type container images may span from 1 to 100 or more in some of the cases. So managing everything individually is a bit challenging. So some form of orchestration is required. The need for orchestration is like, once you deploy this container image in EKS, it will span like 1 or 2 or 3 or whatever instances as we defined in the EKS configuration. But sometimes one instance may shut down or it may crash. At that time, we need to spin up another instance automatically. So that is called orchestration. Similar way, like when some problem happens, it needs to recover. So that kind of orchestration facility is provided by AWS EKS. So majority of the organizational applications, especially if it is a microservice and if it is to be deployed on a container, they go for EKS. And why we are going for a container approach instead of serverless is that, in the case of a container approach, the benefit is like, today we are using AWS EKS. Maybe later we want to go for some other provider, or if we are currently using Amazon, Microsoft Azure, Azure also has a similar EKS. It's called AKS. The name differs, but the concept is same. Both are implementation of the Kubernetes service. So imagine if you are using today the Microsoft Azure AKS, and you developed a set of different microservices for that EKS. If you are planning to migrate that to Amazon EKS, it's much easier, because once you have a base image, it's just a matter of configuration to configure that in AWS EKS. So for the multi-cloud scenarios where organizations using multiple clouds for deploying their container application, this kind of container approach will be beneficial. And also there are another set of benefits also this container provides. Like if you want to run this application on your local machine, you can simply run that inside a Docker desktop, so that it will spin up the required base image and automatically the dependencies along with that. So that's the another benefit of the microservice, because you don't need to have a large set of documentation to install that mentions to install what all are the different dependencies and all. You just need a simple Docker file which specifies what all dependencies are there, including that base operating system. So if you open an existing Docker file, you can see on the top section there is a base image, and underneath that there are a set of dependencies that are specific to the microservice. So that way the container brings a lot of benefits in addition to portability. If you want to move from one cloud provider to a different cloud provider, this offers the EKS. This container provides that benefits. In addition to that, if you want to run it locally also, it brings its own benefits. So if properly defined, everything properly defined in a Docker file, it will be beneficial for the developer as well as for whatever person. They just need a Docker runtime to spin up this instance, and they can do that. And similarly in the cloud also, AWS EKS can spin up that. Think of this in the case of a VM. In the case of a VM, what you need to, instead of this Docker file and all, what you need to do is like, you need to create a front-end microservice, and then you need to deploy that to a server. You need to install the required dependencies there. Then similarly for local development also, you need to have the required dependencies and all. So that's not required in the case. In some cases the editor and all locally can provide its own benefits, but most of the cases the For running that microservice locally, it's much easier with the help of a Docker file. Not just for locally, for deployment also. So that's the reason why here it is mentioned like it avoids vendor locking. Vendor locking means if you are currently with the Microsoft Azure and if you want to move to AWS, in the case of serverless and other specific services, it's not possible because you need to rewrite a code a bit. If you are using serverless technologies like AWS Lambda or something, or Microsoft Azure Functions, you need to rewrite the code a bit to make that application or that service work specifically inside. But in the case of container, that's not required. So these are different set of services. Mostly organization go for orchestration based services. So the three most popular orchestration based services, orchestration based container services that are provided by Amazon is one is Amazon Elastic Container Service, then the Amazon EKS or the Elastic Kubernetes Service. Another one is Red Hat's implementation of same Kubernetes service, which is called Red Hat OpenShift. And if you don't need that much orchestration and you need something simpler, you can go for the other options like AWS Fargate or AWS EC2 or AWS App Runner, which also offers the possibilities for hosting and deploying websites and API in kind of a container approach. Then also there are some supporting tools which can help you with the development like the AWS Aptive Container and AWS Copilot. Aptive Container helps you to migrate your .NET and Java applications to container and can run that in AWS. Next we are going to understand about the benefits that are offered by EKS in particular, Amazon EKS and Amazon Elastic Container Service. So in the previous slide, we understood that are orchestration services. Keep in mind that when it comes to orchestration, it's kind of a full package. So it includes a lot of benefits with additional cost, but the organization can manage it properly. So next we are going to understand specifically about the benefits that are offered by these kind of orchestration services. I'm mostly explaining that in the terms of Amazon EKS, but many of the benefits are applicable to other orchestration service that are provided by AWS as well. First one is like it's a managed service. It means everything which is managed by Amazon itself. You don't need to bother about anything. Everything will be managed by Amazon. You just need to define the container image and you just need to specify the configuration and all. And it's also integrated with other AWS services like the AWS EC2, VPC, Virtual Private Cloud, IAM, EBS and more. So you might be thinking why all these integrations are important and why it is required, because we just need to deploy our container images which we understood earlier. Why the need for this? So when it comes to organization, it's not just a matter of deploying that container image. It's also some additional concerns, like for example, take the case of a security. We need to implement the VPC, and also we need specific users only accessing that container images. So we need some form of identity and access management, which is called the IAM service, which is offered by the AWS. So I will show how you can understand that. So take the let's take that. So this is AWS console. Once you signed on, you can search here IAM. So it will provide you the identity and access management center, and if you open that, here you have the provision to define the users. So if your organization has a set of users, you can define that here. It also provides the facility to connect to an existing on-premise Office 365 account, Azure AD or and many other providers. So that means if your organization has already using Microsoft Office 365, you can have the provision for this identity and access management to connect to there. Similarly, it can also specify the groups, roles, policies. Policies define what user should access particular resource and all. So a lot of these different things can be managed using the identity and access management. And this is another form of service which is offered by AWS, and it can be integrated with different kinds of services that are offered by AWS, including S3. So if you want to define a user and if you want to restrict access to an S3 bucket with just a read-only permission, you can do that with the help of IAM. And similarly, that's also integrated with this Amazon EKS as well. So that means you can have additional facility. So that means you don't need to bother much about the security and all. Everything is there. And if you many forms of application, like takes for example, if you have in this case you consider about a simple website with the two background services, and if you need to store some form of files, a large sized gigabyte sized files to some storage service, you can rely on some of the other service like this is EBS, which is called the Elastic Block Service, and that's also integrated. So these are not the final list, there are many more. Amazon documentation provides all the different details regarding that. So if you have an interest to learn more about the EKS, what I suggest is to go through the AWS documentation. Here it provides the different things, and just click on that container section, and here you can see the Amazon EKS. So if you open that, it provides a different things on how to use the EKS and all. That's a long read, but it's definitely worth to understand all those things. And this definition itself give you a complete picture of what this service offers. It's a managed service, means everything will be taken care of that. So let's look at some of the other things, like it supports automatic Kubernetes provisioning and scaling and reduce cost. That means that you can take for example of the 4 microservices which we understood earlier. We are deploying that to Kubernetes. Imagine if there is a peak load happening on the front end, you can configure the EKS in such a way that it will automatically increase the instances or the copies of that microservices behind the scene, so that automatically your customers will be served accordingly. And it's only charged for that increased cost, and you can also scale down as well. That means if there are not peak load, you can reduce that to 1 instance, and so that means at a particular time you can increase it massively, and at a particular time you can down. Similar way, you can fine grain how you have the liberty to set these kind of provisioning and scaling for different other services as well, like the background services based on different other conditions. For the background service, the number of users may not be a corresponding factor. There you can think about the CPU utilization. If on background service consumes a lot of CPU behind the case, Amazon can detect, EKS can detect that, and it automatically increase the number of instances that way. But the main thing is, like, you have to develop your application in such a way that it supports all this scalability. If you so you need to think about when developing microservice architecture, you need to think about is this application scalable? Is according to the load? Don't think about it's just serving for a single instance. Think about how it behaves when multiple instances of that same application begins to run. So if you think about that, you can understand that many of our applications will break when such a couple of instances spin up. So we need to think about that while developing the application. So microservice architecture is not just about the understanding about the different architecture or the splitting of the domains into different layers, but also about how we create that. Let's look at some of the other things, like it automatically patches. Like this, like we understood earlier, Kubernetes is actually developed by Google, and there is a continuous development happening behind the scene. So that means next day there can be another one improvement coming to that Kubernetes, and it will be automatically patched by this Amazon. If you are installing this Kubernetes onto a local machine, think about the different challenges involved. Like you need to install the Kubernetes, and when there is a new version coming up, you need to think about patching and all. So in this case of EKS, it will be automatically managed by Amazon and for you, but they will be charged accordingly. So that's the thing. Then the other thing is like IPVS, the integration with the AWS IAM, and also it's based cost monitoring at the cluster level and at the individual application level. In the case we have 4 different microservices we just discussed, so they have different cost monitoring also in place. Then logging support is also there with the help of another 2 different services called the AWS CloudTrail and Amazon CloudWatch. So this can, without logging, microservice architecture is difficult to trace, especially when there is a problem happens. So you need a proper mechanism for logging and everything. So that's inbuilt with this this EKS architecture. So now we can speed up a bit more so that, because we need to wind up the session at 9. Sorry for this lengthy time, but I hope we try to cover many of the overviews so that you get a good understanding of that. Second thing is like the other approach. We understood just about the container approach. So next thing is like implementing microservices on AWS using serverless approach. So this is a buzzword nowadays. We seen serverless and all. So if you search into Amazon, let's take that page. Okay, so if you search AWS serverless, it will provide it will provide a page with a definition of what is serverless and what are some of the benefits that it offers, and then it specifically mentions some of the serverless offerings that are made by AWS. So when we see the word serverless, we need to think about it as a kind of an application development where AWS manages most of the infrastructure and all, and you need to just bother about the code and the time it actually runs. So take this case of an website where you need to deploy that website. In most of the time you need to take care of the server and all. You need to patch it, you need to think about that, and you need to configure that. In the case of serverless, you don't need to define that. Many of the things will be defined by the AWS itself. So it's about least bothering about the servers. It's not about entirely eradicating the server. Server is there, but as a developer, you don't need to bother much about that. So that means it's another form of application development, which is a bit different from the container approach. In the container approach, what we do is we create the different modules or the microservices, and then we add a Docker file, and then we deploy that to the EKS. In the case of a serverless, we form that same domain-driven design, and we form microservices, but instead of developing using a specific technology like the specific technology fully, we rely on some of the inbuilt capabilities of AWS to develop that. So that means, let's take the example of the previous application which we just discussed. So this is actually this is our example which we discussed. In in AWS EKS or the container approach, we created that, we add a Docker file and then we create a container image. When it comes to serverless, the method is a bit different. I hope you can see the screen. So there the method is like the first front-end microservice which we created. So this can be hosted on something like Elastic Beanstalk, which is another service offering that is provided by the Amazon Web Service. And then the 3 background service here in container, we created that using some form of backend technologies like the .NET or PHP or Node.js or whatever. It does some form of processing like manipulating the image or something, modifying the documents or something. But in the case of serverless, when it comes, we create these in terms of AWS serverless offering. So one such offering is called the AWS Lambda. So here AWS Lambda, you can create a AWS Lambda. So I can show you that AWS Lambda. I think we just need to type Lambda itself. So this is that. So here once you host your application, that's the first part, this front-end microservice on Elastic Beanstalk, or also if it is a simple website, you can host that in S3 as well. Earlier we understood like S3 is a object storage. It also offers additional provision option to support the website hosting as well. So you can host this in either of these. And the background services which here you defined using some form of .NET service or something, you can define that using the AWS Lambda with your favorite language of your choice. You can have your favorite language and it should be supported by AWS or that particular cloud provider as well. In this case, it supports .NET, .NET Core, Go, Java, Node.js, Python, Ruby, and also custom runtime where you can provide a custom runtime as well. But it's better to go with either of these things unless this is absolutely required. So here they are provided an example like export.handler console.log event return hello from Lambda. So when we run that, it shows the hello from data. So this is just a console logging. Similar way, we can write code here to connect to different services, including the one which we just discussed, like the our website. And it means we can think about some processing to be done on this Elastic Beanstalk or website. We can do that from here itself. So that means here we just write that, we configure that. We can, it's here how it's works is like it's based on a trigger. So based on the triggers, like based on some click or something, if you need this to work, you can define that. So you just write the code and you set up the trigger and all, and then it will work. So let's simply understand a bit. So we can create a function from here. So we can provide a function like my function. We can provide a runtime like a .NET or Java. Let's go with the .NET 6, and then you can go on the advanced setting and you can create that function. So once you create that function, you can define the triggers. So triggers are things which provided by this AWS itself. So that you can connect from different things. For example, if something when you store something in the AWS S3 bucket, if you need this function to execute, you can have that. So this is called the trigger. So you can have these different triggers. So let's take what are all the different triggers that are supported. So if you click here, all the different services that are provided by Amazon Web Services will be defined here. That means when a user is uploading some file into the S3 bucket, you can configure that in such a way that this code, this serverless code, will automatically do the processing behind the scene. So that means you can entirely avoid writing a background service like as you did in container, and you need to pay only for what you are actually using. That means you can configure a trigger, and every time when the user is uploading something into the S3, you can have some processing or code to you can write some code, and you can output that into same like similar like the source. You can have the different destinations as well. So that means if something is uploaded by a user, your website can put it into a specific bucket, and based on that it will raise a trigger which runs this lambda function, and the output can be saved also accordingly. So if you want to write something into a queue, you can have that, and based on that queue you can have another trigger like a function which can be defined, and this way a collection of background functions can be defined with the help of this AWS Lambda. The benefit is like once you define this function, it will be charged only based on the execution. That means if no user is uploading anything into that file, nothing will be charged. So if 3 users are uploading something, 3 times it will run, and that will be charged from your account. So that's called the serverless, and if properly defined, serverless brings a kind of a way by which it's most a cost effective strategy, because you don't need to think about the EKS or container or anything at all. But one of the limitation that it provides is like when it comes to switch to a different cloud provider, like if you want to move from AWS Lambda to something like a different cloud provider, then that will be difficult if you are using this kind of serverless architecture. So that's an overview about the serverless architecture. There are some benefits it's provide. Where API, there is a question where API gateway comes under container approach or serverless approach. It can come under both approaches. API gateway can work with the container approach as well, where you can define a set of APIs and you can manage it using a API gateway, and it can be used by the container or it can be used by the serverless as well. So you can define a set of APIs here, and it can be consumed by the website in serverless that are hosting. So APIs mainly is used by either the front end site or some of the background services. So if in the case of the container service, if you define an API gateway, it can be consumed by your front end microservice website or even the 3 background services as per the requirement. Similarly, when it goes to serverless as well, the same falls there. Like if it's defined using a AWS Lambda, AWS Lambda can use this application gateway as well. The thing is, like in the case of AWS Lambda, API gateway integration is directly there. So that means if some trigger happens in that API gateway, instead of calling that API manually, API gateways API manually, you can have have an integration directly here. And if you check the documentation, you can understand like how to use that API gateway here as well. So these are kind of a 2 different approach. So when a new application development starts, you need to think about these 2 approaches, like the container approach or other approach. And what I understood is like you can have your own research, but what I understood is like container eliminates the vendor lock-in. Like think for example, if you develop an application in this way, it will be the much cost-effective strategy. But if you are planning to move to another cloud provider, that is not required. That is not easy, because you need to entirely rewrite all these background functions into the specific cloud, the target cloud provider which you want to migrate. But the other thing is like another argument I heard in support of the serverless architecture is that most of the organizations stick to some particular cloud provider, like either the Amazon Web Services or some other kind of cloud provider like Azure or Google. So they rarely switch. So most of the case, this kind of lambda based serverless architecture will be fine, because unless they are planning to have a switch, then that's absolutely fine for them. In addition to this, so let's move the okay. So the background processing that, as I explained, the AWS Lambda can be used for that, and also AWS Fargate, which is also another container based approach, but it provides just the compute, not orchestration of anything. That can also be used. Then one thing I not mentioned here is like, we talked a bit about the networking, and in the initial definition of Sam Newman, we understood like there are different services and they are communicating each other through network. But how that communication is happening? There are two forms of communication, like the synchronous and the asynchronous communication. Most of the API calls are kind of a synchronous, where it's actually calling and it's returning. But what about then if the network fails or something? So in that case, instead of two services directly contacting via an API, so let's leave this. Let's take the example of payment and a cart service in microservice. So these are two different services. So when we understood the definition initially, we understood like there is a form of communication that is happening via a common protocol, which can be a simple API call. Just like when we call a website, it's actually calling that cart service, that website through an URL, and it's actually displaying in our browser. So similar way, this payment service, when it needs something, it can contact the cart service through a public interface, and it can return the data. So there will be authentication and everything there. But what happens if the cart service is not available? Like if it is in a maintenance mode or something, what happens? So this will fail. This kind of direct call will fail. So the one of the main characteristics of a properly designed microservice architecture is independent deployability. That means payment service or card service should be stopped or start as far as we like. So there are trade-offs, but most of the case we can stop a service and start it as it like. So that way it should be architected. So this direct synchronous communication is not effective in that case. So instead of that, what we do is like we put that into a simple queue service. So that means payment service will write this into a queue service. So queue is kind of a stack, and then this card service will read that from this SQS service. So that means even if the card service is not available, it will pick the moment it starts resumes function. So this way, this is called an asynchronous communication. So for that purpose, it's called the application integration. So different services are provided by Amazon, called the Amazon Event Bridge, then the SQS simple queue service, then the API gateway for managing the different APIs. So suppose if we have a set of Lambda function which we defined earlier, and we need to provide an API to a different client, maybe for an end user or something, using API gateway we can aggregate that and can provide a common API. So API, different Lambda and API management will be much easier. Similarly, for storing the data, we can have different options in this serverless approach. Like you can host the website on Elastic Beanstalk, or even if it is a simple website, it can be hosted on S3. Similarly, other kind of file storage systems are there. For example, if the application needs to store some form of hierarchical data, like a folder based structure, we can store that in Elastic File System. Then DynamoDB is a kind of a NoSQL approach where we can store the data. So these are different offerings that are provided by Amazon. Also, if you have a big data where a lot of logging data and other things needs to be analyzed and made decisions out of it, you can save that into a warehouse, which is called the Redshift serverless. So each of these are chargeable, and you can check out the cost in these different areas. So based on how you effectively architect, it will be a cost-effective strategy in cloud. Similar to this, a couple of other services also, like the key management stores. Like we are using in whether it's a container approach or a serverless approach, we will be using different services. So it's not good to store the credentials like the keys, the certificates and other things inside the containers or some form of area where others can access. So there is a service provided by AWS called the key management service, where you can store that, and this can be integrated with the different services, including Kubernetes services, Lambda. It can read directly from that key service. So that provides an effectively proper key management service, and you can everything, the keys can be managed under a single area. And one of the main security concerns that are suggested by the Sam Newman in his book is like we should rotate the keys properly, so that it should be limited to one particular service. We should not use a simple key for or simple username and password for the entire different services, because if such key or password is compromised, then we need to reduce the problems associated with that compromise. So we need to limit the keys to particular services, and we should also set expiry and all, and that is possible with the help of automation and key management service, but that involves a lot of additional effort. Similarly, IAM we already discussed, like we can have the identity and management there. Then the another thing is like what all is happening inside these different kinds of services. We can have an audit log using the cloud trail. It will be automatically captured, and we can have a dashboard from the cloud trail. Similar way, you can observe and monitor our different resources like the EKS or S3 using the CloudWatch as well. So you can have the log from the different area in one central place. As we understood earlier, logging is a essential criteria for proper logging is an essential criteria for every microservice architecture. So we need to have that. Next one is like the I have captured some of the screenshots from the AWS websites, the implementation of some simple microservices. This cannot be treated as a complete microservice architecture. This can be think of as a simple module. Like say for example, if an application has a photo uploading domain, you can have a simple microservice like this, which can be owned by a team. So this is an approach using the serverless approach. This is not container based approach. If it's a container based approach, this will be on website which has a Docker file, and we will be deploying that to an EKS. But this is actually a serverless architecture. So here the photograph is taken. So the website will be stored that to an Amazon S3 bucket. So the Lambda is triggered, like as we discussed earlier, the Lambda is triggered, and the Lambda runs. We can write the code inside Lambda based on our favorite language, and photo can be resized into web, mobile and tablet sizes, and it can be further stored in Amazon S3 as well, so that our application can use that thing. So this is on serverless architecture. Here the benefit is like we are just defining this S3 AWS, and we just defining the flow and what we want to achieve. We are not bothering much about the architect, about the server and all, or the setting up. Everything will be managed by Amazon. Next, we look at another serverless architecture, which is also similar, like the Amazon front-end code for weather app is hosted in S3. So this is a simple website, and it can be hosted in S3. So this will be the user interface. So as an user, I will be getting the web page from this S3, and when the user clicks to get local weather information, it will call an Amazon API gateway. So this can be a REST API. Then as we can see from the triggers, we can also define a Lambda can be configured to the API gateway, and it runs the AWS Lambda, and the results can be stored into the DynamoDB. So DynamoDB is another NoSQL database that is provided as a service offering from AWS. So that means our front end can further query from here and can show that. So when they click on that, it will be stored here, and the page which displays the weather information can be retrieved from here. So these are some simple approaches. Second one is like another example, like a user post a status update. So here it's not explicitly shows like where this is actually using from a mobile website. So when a mobile application user when post a status update, it's actually triggering an Amazon API gateway. Behind the scene, Lambda gets triggered and Lambda runs. Then it will be instead of directly posting to friends notification, because maybe a friend's mobile may not be available at that time. So we use a kind of a different approach, like we store that into Amazon simple notification service, and then from there it will automatically notifies the different users whenever they are available. So this way different kinds of architecture you can create using these are kind of a smaller services which are offered by AWS, but you can combine that to form some kind of an architecture. Then these are all that I want to discuss here. Many of the other architectures and about the different services which we discussed today are properly documented in AWS website. So I suggest you to go through there, have a quick understanding of all that, and we can have another session in the coming days, where we can discuss more about each of these specific services in more detail. So that's all about the service microservices and its implementation in AWS. So I recommend you to go through that book by Sam Newman. These are some of the specific things that are related to AWS I mentioned, but if you want to have a generic overview of all the different things, recommend you to go through there. You can understand that. Then that's all about the session, and thank you very much all who are listening this session, and all who are watching this session. Thank you very much, and those who spend time to live watch this session, I thank all of them. And if you want to further check out my videos, you can check out my YouTube channel, including this session. It will be available. Then also I host a meetup group called Coding Talks Cloud Computing, where if you register there, you can get further notification. Also there is an audio podcast which is available on Coding Talks with Vishnu Iji, which is available on all platforms. So if you search, you can these are distinct contents, like some of the contents that I present in podcast are not available in YouTube. Some of the YouTube contents are not available in podcast. So these are distinct contents, so you can check out that. So thank you once again very much. Have a great evening from wherever you are listening. Thank you very much. Yeah, I will add the book names. Book names are Building Microservices and Monolith to Microservices. So thank you everyone once again. Thank you. Have a great evening or morning, from wherever you are listening. Okay, thank you.